Hello everyone, welcome back. Coffee's here. We are ready. And as I mentioned in the past, the boilerplate is gone, right? Yesterday we do all our installation of Kubernetes and all the different single components that you need for a platform, okay? The basic stuff, object storage, computing distribution, and so on and so forth. Today there is the interesting part. So we're going to tweak JupyterLab image with different extensions and different components in order to deploy on demand as soon as a user log in and register, all the services or the ancillary services that you might need. So before going ahead, just let me drop here the chat. I let the chat goes for a while. If you want to say hi and if you connect, yeah, please drop a message. And meanwhile, I'll take the chance to open an Excalibur application so we can track what we are doing. And yeah, so let me take an empty dashboard. Okay, here we are. So again, welcome back everyone. Let me just drink a bit. I need some energy because we are in, well, quite late and we need to do a lot of things. I let the chat here and I take my whiteboard so we can start drawing what we have right now. Okay, so let's start from our Kubernetes cluster. Oopla, what I done? Yeah, our Kubernetes cluster, and we set up this with 10 different nodes. Okay, we have all different nodes in here, and on Kubernetes we installed all the stuff that we need to access stuff from outside. So here there is the user that we're going to use services exposed through the Nginx ingress. Then good. Oops. What? Okay. These are our nodes where we have all the resources. Then on this other side we install different operators. So operators will be the responsible to take our request for each user and create a min IO service, so an object storage dedicated to the users. Oh, I just noticed that there is a chat on top of the plot, but yeah, you should be able to see this anyway. Okay, so if you have any question, drop a message please. Okay, right, so operator minio we have, and then we also installed Dask. We have yet to see them in action, but don't worry, we are arriving there. And this will distribute, Dask will distribute create a cluster for making computing intensive stuff, and this is also part of the school. And then there is the object storage. So we have data and computing under operators, under the operator act. Okay, so this box here are operators and we are good. Then the other part that is missing is, and we just installed yesterday, a basic deployment of a JupyterLab instance. So this will be actually, this guy here will be responsible for giving access to the users to their notebook sessions, right? So they log in, they register through a form with a username and a password, and they are redirected to either one of the nodes that are free. And here they will have sorry, an home directory that should be something like by default Yovian. Okay, and we might see that later on if we want to introduce also another home. Okay, now it's time to remove the chat, sorry, or at least, yeah, another folder that is the persistent one. Okay, so if we want to share on different node a different area, this is something that we should take care of. So this is all we got yesterday. A lot of stuff, right? So I know I'm going to publish a blog post with all the instructions that we executed. You might remember, if you were here, that we had a lot of default installation commands, so nothing particularly intensive. The other part, okay, this is good, this is good. So what is left today? That's a good question. Today we have now the possibility to take our JupyterLab image, and with Docker we compose, we do our magic. So we build an image that has some extensions, and also that will create an MLFlow tracking server dynamically. So when the JupyterLab starts, it will create an MLFlow server. So yeah, so far so good. Why don't we get started, right? So again, this is the topic for today: creating a JupyterLab image. Maybe I have also a nice icon, yeah, that I can use. So creating a JupyterLab image through Docker. So we start from the default image and then we install some other extensions. And after the extensions are installed, we use Git, resource, and we also choose our preferred extensions. If you have one, just drop a message in the chat. And after that, we install also MLFlow to run and expose a service into the JupyterLab as soon as the JupyterLab starts. So the user login has access to the notebook with also the possibility to track their MLFlow experiments. How cool is that? So yeah, if you miss the opportunity to join SOS School, this is a good chance to register for the one that is coming next year. So just consider you invited. All right. So if there are no questions, yeah, let me put some music on. Okay. No other questions from the chat, I suppose. Yes. So we go back to a bit of relaxing stuff before starting with the serious stuff, right? Okay, so let's go back to Blue Sky. You know, it's the trend topic for tech migration right now, so it's quite a nice experience. If you did not log in yet, register and log in. It's full of what was some time ago Twitter for tech guys. So, and also science is populating quite nicely. So for if you are a science person, I have a starter pack that you can take a look at. It's a bit focused on high energy physics, but yeah, you know, you can have some inspiration for following people. So let me just take a look. So yeah, starter pack. You see here there are some experiments, some person from the experiments, and you can get started. Otherwise, there are a lot of pre-cooked starter pack for DevOps and other tech initiative. Other cool stuff of this app is there are what are called feeds. So for instance, I'm now following the KubeCon feed. So since I couldn't make it to be there, so I just take a look and see how it's going. It looks like already rejects. Yesterday was quite interesting, yesterday and before. Now we started definitely with the collocated events. It's very good, I would say. I don't have anything particular to highlight so far, but yeah, guys, take a look. It's everything pretty easy to find out. You see a lot of activity, a lot of people posting, and yeah, I must say, since a couple of weeks, it's crazy, really crazy. Okay. Okay, let me bring back the chat. If you want to say hi and see your message appear, just drop a message. Just drop yeah, a chat. And also, if you have extensions or JupyterLab experience and you want to try something particular, yeah, do the same. All right, let's get started. You remember we have a JupyterLab instance up and running, and the JupyterLab instance up and running, it's kind of cool. We can log in and launch our JupyterLab. Let me increase the size of this a bit, and also yeah, just a second. So we need to go back and take back our values. If you remember, these were our values, and we had the hub that is starting pretty nicely, and then we set up admin users for our authenticator, that is the default one, an ingress path for our wildcard DNS, and eventually now we have to tweak a bit how we manage the resources for each user. So the single user field is how you spawn JupyterLab session, right? So now, first thing we want to do is taking an image, so a JupyterLab image, and make something happening. And by something happening, I mean actually this. So okay, let's close this up. No, let's move to the second tab. Now this is a machine with Docker installed. I hope. Yes. So we are going to make the Docker JLab image. We log in and we create a Docker file. Okay, so this Docker file will contain our image that will be a normal Jupyter / TensorFlow. Yeah, let's take the most complete one. Notebook, Python. Yeah, let's say Python 3.10. Okay, where this image comes from? Stack JupyterLab. Okay, so here in this repository you can take a look to all the possible images available for JupyterLab. No, sorry. Yeah. Okay, where do we see? Okay. Yeah, we should see all the images that are available. And let's take a select an image. So yeah, TensorFlow. Let's see the tags. Okay, we don't need CUDA actually, because we want to have GPUs. Let's see if there is something related to Python. Yes. So we can take Python. Yeah, this one. So this one. Action. No, I want this one. Okay. Quay.io. TensorFlow notebook Python 3.11. Okay, so this is our image, and we need to install some packages. So first thing we do is starting and putting ourselves as root. Then we do apt update, I hope. Let's see. And if it succeeds, apt install -y graphics. We might need this. Then we go back to user. The default user is Jovian, and we run some conda command. So conda install -y -c conda forge. We install Dask and distributed. Okay, so these are the packages needed to a client level to use a Dask cluster. Then we have also additional packages. For instance, we need to install about 2, 3 graphics. Oops. And graph-vids. Okay. And yeah, let's take this for granted. Okay, so Papermill is quite interesting. I don't know if you know already. It's a simple but yet powerful Papermill Jupyter utility that allow you to execute notebook just like they were executable scripts, right? And create as output all the notebooks but we filled plots and images. So yeah, if you didn't know yet, definitely I recommend taking a look. So paper mill, then we need pillow, TQDM, and eventually MLFlow. Okay, this is for tracking machine learning algorithm. I don't know if we need anything else. Let me check my notes. Yes and no. Yeah, let's do this as well. So run make dir. We put into, since we are as user Jovian and not as root, we create a nom bean and data directory. Yes, and then we do run make dir. No, and then we download minio client to interact with the storage. Okay, minio client that is called MC. Okay, yeah, it's called minio client. And to install MC, yes, exactly, we need this. Okay, so create this. Okay, well, never mind, we already created. So being MC, then there is, if everything succeeds, we go ahead and say this, and again, if everything succeeds, oops, this is bin,